We're going to talk about problem number 6 here. I know the idea is slightly confusing. First of all, you were given the velocity function. You are looking for the idea of displacement or distance traveled. So displacement essentially takes derivative, gives you velocity. Velocity takes derivative, gives you acceleration. So conceptually, this problem is like if your displacement is f of x, I'm giving you the velocity, which is f prime of x. So you are looking for the area under the velocity function, namely you want to integrate the velocity function so as to find the area underneath it, which is reconstructing the original function, which is displacement. So the first part, in order to find your displacement, you are actually looking for integrate your function in the interval. So let's see, it's in the interval 0, 1, 2, 3, 4, 5, 6, 7, 8. So 0 through 8. And you have your function given and dt. That's what you're looking for. And you can only do it with the help of Riemann sum because the original function was not actually given to you explicitly. So you are trying to find out the Riemann sum area, and they are telling you to use a left end Riemann sum. So they kind of plotted the graph for you already. So what you can do is you can find the area of each part of it. So this is a height of 2. This is base of 1. So this one has an area of 2. This one has base 1, height 4. So area of 4. Base 1, height 2. So this is area of 2. Area of 1. Area of 1, 2, 3, 4. Area of 3. Base 1. So area 3. Height 4, base 1, area 4. Height 3, base 1, which is 3. Well, you do need to be very careful. I mentioned earlier that it's supposed to be net area, hence it's the sign. It's going to matter based on your location. You are going to mark the sign for those. Therefore, the net area of this, which is a displacement, which is the integration of the velocity function, is -2, add to -4, add to -2, add to -1, add to -4, add to 3, add to 4, add to 3, which is your displacement. Well, you may say, what about the other one? What about the distance traveled? Well, distance traveled is not net area. They are no longer considering the direction. So naively speaking, if this is where I am, going negative means I'm moving towards a negative direction. Negative direction. Having a positive area means I'm moving towards the positive direction. So your displacement consider the direction you are moving. However, the area, the distance you traveled from here to here, from here to here, even if you walk back to the origin, your displacement is 0, but you traveled all those pieces. So every single region you consider is supposed to be making positive contribution because direction doesn't matter anymore. So naively speaking, what you are calculating is flipping this whole region to the positive side. Therefore, you are trying to calculate something which looks like this. I'm flipping this back to the top, and this, and that, and that, and that. So that's what actually you're calculating. So everything you had was negative before is now positive. So it's 2, 4, 2, 1, 4. So you're adding all those together. So the distance traveled is treating all the regions as a positive. So 2 plus 4 plus 2 plus 1 plus 4 plus 3 plus 4 plus 3. Of course, you can figure out both answers. That's supposed to be telling you what's your total displacement and total distance traveled with the left and Riemann sum. And once you did that, it shouldn't be too hard to do the exact same discussion when you use the right and the Riemann sum. I do want to bring to your attention the question asks to carry the units in the discussion. So whatever you have as a final answer, please make sure you are using the proper units, right? Go back to the original problem. Your distance traveled should be having feet as your unit. So please include that in your discussion. And this is how we are going to solve problem number 6.